Yeah, what are we talking about today?
So please, I want to know what logarithms and exponents are and how they are important in our everyday lives.
All right, so practically, I would want to talk about logarithms this time around, not just with formulas and mathematical expressions, but I would want to explain the concept or the idea behind logarithms. Now, way before John Napier invented what we know as logarithms, and what we usually learn in our textbooks in the 1500s or 1500s to 1600s, along those periods, people were already fascinated about things growing, about things compounding. So they were already used to addition. One goes to two, two goes to three. You're adding on things. But the next question is about increase. And that's how things usually happen in the real world. You can see that money compounds. Then you can also see that bacteria divides and then they multiply very, very fast. So we are considering how things are moving. For example, 2 can become 4, 4 can become 8, 8 can become 16 in that order. Or we have 10, 10 becoming 100, thousands, and stuff like that. So when we are looking at logarithm, we are talking about how many growth steps have took us to a certain number. So 10 goes, or when I say something like 10 to the power 3 is equal to 1000. By that saying that it took 1000, sorry, it took 10 3 steps to multiply itself to get to 1000. So mathematically, we may say that okay, log to the base 10 of 1000 is equal to 3. I'm trying to answer the question that how many times did it take 10 to multiply itself to get to 1000, or 10 to get to 100? That would be 2 growth steps. So if we talk about exponents, we are looking at if I grow a base by a certain number, what will I get? So if I grow a certain base 10 by a number like 3, I'm going to get 1000. If I grow a base 10 by 4, I'm going to get 10,000, right? But in logarithm, I'm trying to reverse that. I'm trying to say if I reach a number, how many growth steps did I take to get to that number? So if I reach a number like 10,000, I'm trying to ask myself, okay, if it is 10, if 10 begins the journey, how many steps did it take to get to 10,000? And that's 4. So we'll call that log to the base 10 of 1000 is equal to 4. So in a nutshell, we say that logarithms give you the history of a certain process and not just numbers. So that's the idea. Yeah.
So please, I heard I cannot find the log of a negative number. Why is that?
Yeah, so we can't find the log of a negative number. If you take something like log to the base 10 of log to the base 10 of 10, I'm trying to say that how many times will 10 raised to the power what gives you 10. When I say, and then you tell me that that's 1. When I say log to the base 10 of 100, you're asking the question that 10 raised to the power what gives you 100, and that's going to be 2. Now, when I say log to the base 10 of, say, negative 10, I'm asking the question that 10 raised to the power what gives you negative 10, and it's nothing. Even if you say 10 raised to the power negative 1, you are supposed to get 0.1, right? Or when I say 10 raised to the power 0, I would also get 1. Or 10 raised, so there's no number that raised to the power, or there's no number that you can raise the power to get a negative value. I think let's put it that way. Yeah, I think that's it. Yeah,
Thank
maybe
you.
practical applications of logarithms. That's also something you now meet it in. Like I mentioned, compound interest. You see logarithms there, and even you also when you learn chemistry, you learn about acid strength and all of that. You also learn logarithm over there, and they'll be useful in all those fields. And also exponential decay, how fast something is decaying. So you're not looking at the thing decaying by 1 to 2 to 3, like decaying from levels. It was 10, it was, let's say, 1000 initially, drops to 100, then drops to 10, in those order of things. So exponential growth and exponential decay, which are things happening in our everyday life, would all depend largely on logarithms. So that's how it works. Yeah. All right.